All right, so what up, dudes? We're going to take a look at this graph, and from that graph, we should be able to glean a bunch of information. Let me just click something real quick, and then I'll get started again. Hold on. Yeah, I'm sure. Why would I press that if I didn't do that? All right. What up, dudes? We're going to be graphing this function right here. Actually, we already graphed it. The thing we're going to do is we're going to be able to glean some information off of this graph. We're going to see this graph and we're going to take some information off here. If you were to look at the actual graph, they have a nice little grid line and all that kind of stuff. I didn't draw it up pretty, but essentially I'm going to put some relevant information over here. This point right here is 0, 3. This point right here is 1, 7, and this point right here is -1, 1. I just gave you the x and y coordinates of these 3 points right here. Now, this is a line. This is a linear function. From the graph, can you tell what the y-intercept is? Well, the y-intercept is pretty simple. It's basically where x equals 3, or no, x equals 0, and what is the y value at x equals 0? Basically, where does this thing cross the y-axis? This vertical axis being the y-axis, that crosses at the number 3. Where are we? I was here last. Oh, okay. Well, I'm sorry. I'm reading what they're saying. We're on linear functions 3. And I know that this is, what I'm doing is I'm recording stuff that is 1 or like 2 weeks in advance. So, you should probably be doing homework on linear 1 and 2 by now, but I'm going to cover linear 3 because I already covered linear 1 and 2 with you. All right, so the y-intercept for this thing is this point right here, or I guess the best way to do it would be, the point is 0, 3, but a lot of times we assume that you already know that the x value is 0, so we just say it's 3. That would be the point at which this graph crosses the y-axis. All right, what's the slope? Okay, there's an easy way to do it and there's a harder way to do it. The harder way is, and it's not really that bad, but it's m is equal to delta y over delta x. What I mean by that is the delta actually means the change in. It means you take the final spot and you minus the initial spot. This, basically, it's saying this is the rise, because the rise is how much up you go, divided by the run, how far across you went. And you can do this with any 2 of these points. You just need to choose 2 of them. So one of those points could be 1, 7, and the other point could be 0, 3. So what I would do is the delta y is equal to y2 minus y1. It's basically saying the change in y divided by x2 minus x1. And you just plug it in here. For y2, we're going to use 7. For y1, we're going to use 3. Equals 7 minus 3. Maybe I should just do it over here. 7 minus 3 divided by, for the x2, we're going to use 1. For the x1, we're going to use 0. So that's what, 4 over 1? Which is, the slope is 4 over 1. All right, what's your thoughts? Is that all right? Did you guys hang with that? All right. Quite often, what I like to do, now that's the complicated way, and I hate to say complicated because it's not really even that bad. It's simply rise over run. That's all I did, was rise over run. I guess the concept that I like doing is when I have a graph to deal with, and sometimes if they just give me 2 numbers, I actually just graph it out and I think about this. If I start at this point right here, and I want to get to that point right there, these are solid points that I know. What was my rise? The rise is how much? If I start here down at -1, this is y equals -1. How high up did I have to go to get to here? I had to go 1, 2, 3, 4. I had to go 4 up. That's my rise. How far across did I have to go to get to this point right here? Well, that's only 1. Same answer. Now, Leanna, you said 5. No, it's not 5 because we started at -1. We only went up to 3. So I go 1, 2, 3, 4 up. That's my rise. And 1 across. And that would get me from this point to this point. So this is the easy way of finding slope. If you have the graph, it's pretty easy. I think it's pretty easy. It's a lot easier than this. I like both ways because sometimes you can't make a really nice, accurate graph, so you need this equation. But sometimes you can make it a quick, accurate graph, or sometimes they even give you the graph, and then you can just read it at this point. And I told you, you don't need to use just these 2 points or these 2 points. You can even use like from here to here. If I wanted to go from -1 all the way up to +7, I would go up 8, right? And then if I want to go from here to here, I would have to go across 2, so that's 8 over 2, also known as 4 over 1. Boom, same slope. Does that make sense to you? All right. So we're pretty thoroughly convinced that the slope of this thing is 4 over 1. And you can figure out how to get that any way you want. Now, if I were to write down the equation of this line, the equation that I know of a line is y equals mx plus b. M being the slope. So if I wanted to write the actual equation of this line, it'd be y equals 4x plus 3. Because my 4 is the slope, and my b is the y-intercept. It's the number 3. That's simply it. All right, let's see. Use this answer to figure out what f of -1 is. Now, what I mean by that is, you know how I said this is y? A lot of times we interchange that with f of x. And I've taught you that concept before. It's kind of like, this is a function of x. So if I say f of -1, that means, what is the value of this function when I have x equal to -1? You simply plug in -1 into here, and we'll see what we get. We have 4 times -1 plus 3. What is that? -4 plus 3? That's equal to -1. Does that make sense? Yes, it makes sense, because look, at x equals -1, y equals, or f of x in this case, -1. I mean, shoot, let's try x equals +1. What is f of 1? That's 4 times 1 plus 3. That's 7. Right? Because if I have x equals +1, the y value is +7. See, all we're doing when we solve these problems is we're just kind of pulling this information out. We're using the equation to help us get the graph. Or maybe backwards, we're using the graph to help us get the equation. But what's nice about the equation is if I asked you, well, what is f of -4? See, the problem is, if I were to do it on the graph, I would have to draw a really long line, and the answer would be way down here, and it would be hard for me to see. But if I have the equation, which is always really nice, I can simply plug in -4 into this thing. So we have 4 times -4 plus 3. All I did was I plugged in -4 for x over here. 4 times -4, that's -16, plus 3, that's -13. That's my answer, -13. Because it means that if I am standing out at -4, I would, that line would cross that, -4 point at -13. And what's really nice about this is that, yes, you can get the information really quickly when you see a graph, but what's nice about having the equation is that you can kind of predict the past or the future. What I mean by that is you can kind of see a trend, and then you can see what will happen as it goes further out. Much further than maybe the graph can go. You guys see what I mean? So having both things is really powerful. Being able to see a graph, and then taking that graph and turning it into an equation. All right, how do you guys feel about that? We good? Awesome.